Hello my dear students. We are moving to the next lesson today. It is refraction of light. Light travels with different speed in different media. It travels faster in air than in water or in glass. The speed of light is maximum in air and which is equal to 3 into 10 raised to 8 meter per second. The speed of light in a medium decides the optical density of the medium. A medium is said to be optically denser if light slows down in it, and it is said to be optically rarer if light speeds up in it. As we all know, light travels in a straight line, which is called rectilinear property of light. When a ray of light traveling in a transparent medium strikes obliquely at the surface of another transparent medium, a part of light returns back to the same medium obeying laws of reflection. This is called reflected light. The remaining part passes into the other medium and travels in a direction different from its initial direction. This is called refracted light. Thus, at the boundary separating two media, light suffers partial reflection and partial refraction. So, refraction is the change in direction of path of light when it passes from one transparent medium to another transparent medium. In this lesson, we are going to learn more about refraction of light. Let's look the refraction of light in different cases. When a ray of light travels from air to glass, it bends towards the normal. Here, air is a rarer medium and glass is the denser medium. So we can say that when a ray of light travels from a rarer medium to a denser medium, bent towards the normal. In this case, the deviation produced by the ray will be equal to I minus R. But we can observe that if the light ray passes from glass to air, bends away from the normal. Hence, when a ray of light travels from a denser medium to a rarer medium, bends away from the normal. Here, the angle of refraction R will be greater than the angle of incidence I, and the deviation of the ray is R minus I. Hence, the refraction happens due to difference in optical density of the media. But we can notice one thing, that when a ray of light incident normally on the surface separating two media passes undeviated. Here, the angle of incidence I is equal to 0 degree, and then the angle of refraction R also will be equal to 0 degree. The deviation of the ray is 0 here. That means the ray of light doesn't suffer any refraction, and the ray of light does not refract it even if the optical density of the medium is different. So the condition for no change in direction of light ray on refraction is when angle of incidence at the boundary of two media is 0, that is, the light falls normally on the surface separating the two media, and secondly, when the optical density of both the mediums are same. For example, when light ray passes from vacuum to air, it does not suffer any refraction because speed of light in vacuum and in air is same, and hence the optical density of both the mediums are same. Hence we can conclude the refraction happens because of change in speed of light from one medium to another, and it depends on the optical density of the medium. The refraction of light obeys two laws of refraction. The first one is the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. And the second one is the ratio of sine of the angle of incidence I to the sine of the angle of refraction R is a constant for a pair of given media. That is, sin I by sin R is a constant. This constant is called refractive index of the second medium with respect to the first medium. The above laws are called Snell's laws. So, refractive index is an important factor during refraction of light. Let's look in detail about refractive index. As Snell's law said, refractive index of the second medium with respect to the first medium is defined as the ratio of sine of the angle of incidence in the first medium to the sine of the angle of refraction in the second medium. The refractive index is denoted by the symbol mu. So, refractive index of the second medium with respect to first medium is denoted like this. This refractive index has no unit as it is the ratio of two similar quantities. As we all know, refraction directly related to the speed of light in a medium. So, we can connect refractive index with the speed of light in such a way that the refractive index of the second medium with respect to the first medium is equal to the ratio of the speed of light in the first medium to the speed of light in the second medium. In the case of all the waves, including light waves, the speed of light, the frequency and the wavelength of light is related by the wave equation V is equal to F lambda, where V is the speed of light, F is the frequency of light and lambda is the wavelength of light. Here, the speed depends on the media which passes the light, but the frequency depends only the source of light, and hence wavelength changes with change in media. Hence, during refraction, speed of light and wavelength of light changes and the frequency of light remains same. Hence, we can write the refractive index is equal to speed of light in medium 1 by speed of light in medium 2, which is equal to frequency into wavelength of light in medium 1 by wavelength of light in medium 2. Since frequency is same in both the media, we can write the refractive index is equal to the ratio of wavelength of light in medium 1 by wavelength of light in medium 2. Hence, we can define refractive index of the second medium with respect to the first medium in three ways, as it is the ratio of the sine of the angle of incidence to the sine of the angle of refraction, or it is the ratio of speed of light in the first medium by speed of light in second medium, or it is the ratio of wavelength of light in first medium to the wavelength of light in second medium. Now, if the refractive index of a medium is defined with respect to vacuum, then it is called absolute refractive index or simply refractive index. Hence, the absolute refractive index or refractive index of a medium is defined as the ratio of the speed of light in vacuum or in air by the speed of light in that medium, or it can be defined as the wavelength of light in vacuum by the wavelength of light in that media. The absolute refractive index is always greater than 1 since speed of light in vacuum is maximum. The medium with minimum absolute refractive index is vacuum or air, and which is equal to 1. All the other mediums are having absolute refractive index greater than 1. For example, in water, absolute refractive index is 1.33 and normal glass has absolute refractive index 1.5. Diamond has maximum absolute refractive index which is equal to 2.4. The absolute refractive index gives a clear idea about the speed of light. For example, the absolute refractive index of diamond is 2.4 means that the light travels in air 2.4 times faster than in diamond. Or the absolute refractive index of water is 1.33 means that the speed of light in air is 1.33 times faster than that of water. So, if both the mediums are having same refractive index, the light ray will not suffer refraction when it passes. The symbol of absolute refractive index is mu. Now let's look the factors affecting the refractive index of a medium. The refractive index of a medium depends on three factors. Nature of the medium. Smaller the speed of light in a medium relative to air, higher is the refractive index of that medium. Second is physical conditions such as temperature. With increase in temperature, the speed of light in a medium increases, so the refractive index of a medium decreases. And finally, color or wavelength of light. The speed of light of all colors is same in air, but in any other transparent medium, the speed of light is different for different colors. The red light travels faster than the violet light since the wavelength of red light is more and the wavelength of violet light is less. Hence, refractive index of a medium increases with decrease in wavelength. Here, the refractive index of a medium is more for violet light and less for red light. Principle of reversibility of path of light. According to this principle, the path of a light ray is reversible. For example, if a light ray passes from water to glass with an angle of incidence A, refracted with an angle of refraction B in glass. Here, the refractive index of glass with respect to water is sin A by sin B. Here, according to principle of reversibility of light, for all the rays of light falls from glass to water with an angle of incidence B will refract with an angle of refraction A, and hence the refractive index of water with respect to glass is sin B by sin A. Hence we can conclude, according to principle of reversibility of light, the refractive index of the first medium with respect to the second medium will be equal to the reciprocal of the refractive index of the second medium with respect to the first medium. Thus, if refractive index of glass with respect to air is 3 by 2, then the refractive index of air with respect to glass will be 2 by 3. Hope you all understood what I taught you today. Thank you and have a nice day.